So welcome this evening to this lecture on hoisting in JavaScript. And tonight we're going to look at how hoisting works, what it is, look into it a little bit deeper, so hopefully we get a better understanding of it. It's one of the JavaScript subtleties that can easily be overlooked, and sometimes when we're debugging and trying to figure out what's going on with our code, if we don't understand hoisting and how it works correctly, then we might be looking all over the place, and it's just in how we have declared a variable or a function or something and how we've initialized it somewhere else, and it's just how the code is moving around in the interpreter and not exactly what's going on with how our code is written. So the interpreter will do things to our code, and that's something that we don't see since JavaScript isn't compiled, so to speak, like other languages where you have to actually run a compiler for your code and generate new code before you can even use it. We don't see that step. It's built into the interpreter. However, it does happen. So understanding some of these things in JavaScript definitely will make us better developers, and understanding the deeper how the code works deeper is going to only be beneficial for us in the end. So let me take a quick little poll of everybody here and just throw it into the chat. And I want to go from 0 to 5, how comfortable you are with hoisting. So 0 would be you never even heard about it. You just saw this study group and jumped into it. And 5 would be, you understand it completely well and you're just here for review. So I got 2.5, 2.5 also. Excuse me. Cool, 0. That's awesome. Yeah, I don't think it's past any amount of understanding, and this is perfect for everybody, I think. So, we'll jump right into hoisting. So, hoisting is a JavaScript mechanism where variables and function declarations are moved to the top of their scope before code execution. So, this means that no matter where functions and variables are declared, they are being moved to the top of their scope, regardless of whether their scope is global or local. And we're going to look at examples of this, so if just hearing the words isn't clear, don't worry, we're going to jump into some code to show this. Now, of note is the fact that the hoisting mechanism only moves the declaration. So the assignments are left in place. And one of the, I think, most popular JavaScript patterns is declaring and assigning variables in the same place. So we don't see this often in JavaScript, but it can be done, and we'll look at some examples of that and how that can affect things. So if we've ever wondered and seen this in code and wondered, how you can call a function on, say, line 5, but that function was written and defined on line 25, then this is going to explain and solve that mystery for you. So first things first, let's look at, sorry, got my headphone cable across my keyboard. So let's look at something. So let's say console log type of, we'll just say variable. When we run this code, we get undefined. So our first point is, in JavaScript, an undeclared variable, so this is turning into a variable, is assigned the value undefined at execution and is also of type undefined. So if we look at, instead of just the type of, we just look at a console log of the variable, we will return, I guess I can pull this up a little bit, reference error. Variable is not defined. So in JavaScript, a reference error is thrown when trying to access a previously undeclared variable. So the behavior of JavaScript when handling variables becomes nuanced and is very subtle because of hoisting. And this is what we're going to look at in depth this evening. So let's look at this image. So this is the JavaScript lifecycle and is indicative of the sequence in which variable declaration and initialization occurs. So we have a declaration, initialization, and then assignment, or assignment, just two words for the same thing, and then the usage. So what's happening in our JavaScript lifecycle in the execution is a variable is being created, declared, then it's being assigned or initialized, and then it's being used somewhere. We're getting this all, this is our lifecycle, this is our flow. And JavaScript allows us to both declare and initialize our variables simultaneously. So our most used pattern is this right here, this var a equals 100. And we're going to get into ES5 and ES6 and the differences as well this evening. So don't worry about that. So this is how we're seeing most of our code. We're declaring and initializing on the same line. However, we have to remember that in the background, JavaScript is religiously breaking that apart and doing a declare and an initialize, an assignment separately, and then using the code, our variable. So as mentioned earlier at the beginning, all variable and function declarations are hoisted to the top of their scope. And in addition, variable declarations are processed before any code is executed. So these variable declarations are all happening before any code gets executed. Now, in contrast, undeclared variables do not exist until code assigning them is executed. And therefore, assigning a variable to an undeclared variable implicitly creates it as a global variable when the assignment is executed. And I know that's probably hard to keep track of just listening to it, and we're going to look at examples. So this means that all undeclared variables are global variables. And let's demonstrate this behavior. Let's make a function called hoist. Seems appropriate. We'll say a equals 10, var b equals, say, 100. And let's call that function, execute that function here. We'll say console log a. So before we run this, any guesses as to what we're going to find in our console? Okay, so we get 10. And that's because this a is a global variable, and it is accessible outside of this function hoist. So if we look at console log b, we will see a different story. We get a reference error, b is not defined. Now this is because since it is declared, it is confined to the function scope of hoist here. So we can't print it outside of the confines of the hoist function. And thus we get our ref b is not defined when we try and console log it here outside of the scope of this function. And you can think of the scope as between the curly braces. That, I think, is the easiest way to keep track of the scope of things. And it can get a little bit complicated when you're nesting functions inside of each other and things like that, because the scopes are going to be nested. However, the scope, I think, is easiest to just look at the two curly braces, and that's the scope of the block. So this is one of the subtleties, I was going to say eccentricities, but subtleties is easier to say, of how JavaScript handles variables. So this is why it is recommended, and we typically see, and it's taught, to always declare variables regardless of whether they are in a function or global scope. And by declaring, we're meaning using var or let or const, and not just setting up a global like this one is right here. And this clearly delineates for us how the interpreter should handle them at runtime. We're looking at them, it's going to be a visual indicator and help us know the scope that these variables are a part of. So now let's look at ES5. And we have this var declaration. So the scope of a variable declared with the keyword var is the current execution context. So this is either the enclosing function, or for variables declared outside of any function, global. So we can look at a couple examples of this. So let's say console log, we'll say hoist again. We'll use that throughout tonight. And we can say var hoist equals this is being hoisted. Let's throw a period in there just for proper grammar. Okay. So if we think about this, we might be expecting a reference error. Like before we got a reference error, B is not defined. So here we might be expecting a reference error, hoist is not defined. When we run this, we see undefined. And it's like, why is this undefined? And that is because of hoisting. And this is bringing us closer to our understanding of what hoisting is doing. So JavaScript has hoisted the variable declaration. If we remember, the declaration and the initialization are happening separately. And so the code looks more, the interpreter isn't seeing the code this way. It's looking more something like this. So the interpreter is taking our code that we had and it's saying, okay, I'm going to declare the variable, then we're going to console log it, but because it hasn't been assigned to anything, it's coming back undefined. And then we're going to set it equal to this string. So this is what the interpreter is seeing when your code runs. So because of this, we can use variables before we declare them. However, we have to be careful because the hoisted variable is initialized with the value of undefined. So once again, our best option is to declare and assign our variables before we use them. Meaning, follow your code down. So you want to declare and assign it before you use it. Is everybody keeping up? Is this making sense? Any questions so far?
I'm good, thanks.
Okay. If you have any questions, just shout them out over the microphone or throw them in the chat, and I'll stop and we'll chat more about things. So now let's look at function scoped variables. So we looked a little bit at a global scoped variable. We can look at function scoped variables. So we saw here that variables within a global scope are hoisted to the top of the scope. And let's look at function scope now. So let's function hoist, console log, the message, say message equals hoisting stuff is fine. And then let's call that. And we'll run it, and let's see what we get. Undefined. So just like our global scope, we have a scope here inside this function, from here to here. And the declaration is going to be hoisted to the top of the function scope. So just like we saw before, the interpreter is seeing something like this. So it's declaring this variable, but it doesn't have anything when it's here, so it's undefined. Then here we set it equal to the string. So that's why we get our undefined. So once again, to avoid this, we can declare and assign on the same line. And we will see that now we get our string. So right now, if you're writing JavaScript, you're probably not writing in, oh, let me see. What would be an example of when you would want to declare and assign message after console log, if any? Let's go backwards. Like
so just looking at that example that you have there, I understand why you would want to declare and initialize at the beginning, but is there any instance in which you would want to declare and initialize after you have executed something?
Not that I can think of off the top of my head. Probably because from the beginning of my learning, that the pattern of declaring and initializing before you would use a variable was taught to me, and that's how I learned it. So the concept doesn't really ring true in my mind. I think it comes more from other languages. Like I've seen some Java stuff where even though you're allowed to declare and initialize on the same line, it's like it's better to do it inside of the class but outside of the function, and then set it equal to something inside of the function. Or it's, I don't know, there's some odd things out there. And I think the pattern of doing stuff like this comes from other places where you can't declare and initialize on the same line. So I think, or maybe in JavaScript's history, it wasn't always possible. So people got used to doing it a little bit differently. And that's where this sort of pattern could come from. But really, I'm kind of forcing this to show what happens. The idea would be that you wouldn't use the message that's declared on line 2 before it's assigned to something, because that would introduce bugs in your code when you have something that you think is a string or is sometimes a string, and then it's undefined, one time or maybe for a few iterations until something gets assigned to it. So the fact that the function changes or the value changes is going to make your code kind of hard to maintain.
Okay, sounds good. Thank you.
You're welcome. So let's go over. Oh, so you might find yourself working in ES5 and ES5 only. My first developer job, all of our JavaScript was written in ES5. It's just how it was. So even though I wanted to write everything in ES6 and we had the build tools to do that, I couldn't just, start writing new code that's completely different in how its pattern is from all the old code. It would be a visual stumbling block to everybody else, because they would see it, and not that they wouldn't understand it, but there was a pattern of, okay, when we look at a React component, it always looks like this. This is how it works. And then if they jumped into another one and it was structured completely differently, it'd be a whole different process to debug and view and look at that code. So something that we can do in ES5 is use something called strict mode. And this will force us to be more careful about how we declare our variables. And by enabling strict mode, we explicitly will opt in to a restricted variant, I guess restricted is the best word, of JavaScript that will not tolerate the usage of variables before they are declared. So strict mode there's a whole list of things that strict mode does, but I'm just going to concentrate on some of the bigger ones that are directed towards this. And it eliminates some of the silent JavaScript errors by changing them to explicitly throw errors, which will be spit out by the interpreter. So one reason that people love JavaScript and one reason that people hate JavaScript is that it allows you to do a lot of things that maybe, you shouldn't be able to, some people would say. So instead of spitting out an error, sometimes it's like, that's not so bad. I'm just going to keep going and let it do its thing. So strict mode isn't going to allow all of those things to happen. It's going to allow some of them still, but it's going to explicitly error on some of the other ones. It will also fix mistakes that make it difficult for JavaScript engines to perform optimizations. And it also prohibits some syntax likely to be defined in future versions of JavaScript. So we can enable strict mode in our code simply by typing the string use strict at the top of our file. And that can be single or double quotes. And that will enable JavaScript on our entire, or strict mode on our entire file. So if we do something like console log hoist, and we say hoist equals hoisted, and we saw before that this global should get hoisted to the top of the scope and be declared there. So we should get undefined. Let's see if we get undefined. No, we get a reference error. Hoist is not defined. So that's strict mode, enforcing on us a explicit reference error. We can see that instead of assuming that, we did something wrong, use strict has, or assuming that we missed, declaring it or how it's interpreting it, use strict has stopped us in our tracks and explicitly thrown a reference error. So strict mode behaves differently in different browsers, however, so relying on it to keep our code exactly where it should be backed up by a lot of testing in browsers. So just a caveat of using use strict. Also, use strict, if you don't want to use it through your entire file, can be scoped the same way into a function. So you could say function, strict function, and you just add it to the top of your function. Now all the code inside of this function will have strict mode enforced, but all the code outside of it will not. So I enjoyed using use strict and strict mode. It forced me to understand my code a little bit better and to throw some errors that I wouldn't have thrown, and just enforce kind of some what some people, because everything is opinion, consider best practices. So I really enjoyed writing in it, especially learning, and I don't use ES5 as much. It's not something that works in ES6. I don't think. I guess I've never tried it, but I know it's specifically targeted at ES5 because of that. So now let's look at ES6. So ES6 being ECMAScript 6 or ECMAScript 25 is a version of the ECMAScript standard and introduces a bunch of changes to ES5. But of interest to us is how changes in the standard affected the declaration and initialization of JavaScript variables. So before we get going in ES6, it should be noted that the fact that variables declared with the keyword let are block scoped and not function scoped is significant. So it shouldn't be something that we worry about right now, but just wanted to make sure that it was mentioned. And it means that the variable's scope is bound to the block in which it is declared and not the function in which it is declared, which is different than var. So specifically, I saw this very recently in a developer Slack that I'm a part of here locally. Let's say just a loop example. So we've got some code going on, like message equals message. Then we have something that we want to loop over. I equals 0. I less than, say we got array dot length I plus plus. Then we have a loop of doing something, and then we'll return something. Let's say message plus equals string interpolate the I onto the end, and then return message. There. It's a function that actually means something, although we won't be calling it. So this I right here that we declare is only available inside this block. Whereas if this was var I, it would be available outside this block as well. So it's scoped into the block, and that's it, which is a little bit different. Okay. So let's look at what let does. And we'll follow some of our common or familiar examples. Okay, so to review, when we used var, we got a undefined here because var put the declaration above the console log and then the assignment after it. So if let works like var, we should expect the same. However, we get a reference error, and it says hoist is not defined. And this looks very similar to our strict mode, or it's even pointing at the same spot. So ES6's let doesn't take kindly on us using undeclared variables. So the interpreter is explicitly spitting out a reference error to us. And this is going to ensure that we always declare our variables first. There's no way to not declare them first. Oh, sorry. However, we can still explicitly declare them first and not assign them. And we will get our undefined. So as we've been saying, or I guess as I've been saying throughout this lecture, to ensure that we don't introduce any bugs because of undefineds in our code, it's always best practice to declare and assign our variables on the same line. Now to const. So the const keyword is introduced to allow immutable variables. So that is variables whose value cannot be modified once assigned. So with const, just as with let, the variable is hoisted to the top of the block. So the hoisting acts the same as let. So that isn't anything different. And we'll see that in our example of console log hoist. Hoist equals once again, a reference error, hoist is not defined. So now let's look at how what const does when we try and reassign a variable. So we were talking about immutable variables. So pi, let's be more specific, 22 divided by 7. and console log pi, and see what we get. Okay, so when we get to our line 3, we get this type error, assignment to constant variable. So it's not going to let us change what pi is equal to. It's immutable, can't be changed. And when we use const inside a function, let's say conference with a radius, just a tiny bit of for us. Log circumference, and circumference equals pi times radius times 2. Const pi equals 2 divided by 7. Let's call this function. We'll throw a 2 in there. And see what we get. Oh, reference error. Circumference is not defined. So we're throwing an error on our second line because circumference isn't being defined. And that is because ES6 is going even further. And even though we have this global, it's being a constant is being used before it is declared and initialized. So this constant pi is throwing the error on this circumference. So it's kind of chaining it through it. And that's where we got the issue. So globally, const pi, console log pi equals 22 divided by 7. Just like with let. Oh, this is a different error, but missing initializer in const declaration. So it's telling us we're declaring it, but we're not initializing it. So we need that in our declaration. They come together as a pair. So it is important to note that JavaScript does hoist variables declared with let and const, which probably is confusing at this point because it looks like they don't. The difference in this case is how it initializes them. So variables declared with let and const remain uninitialized at the beginning of execution, while variables declared with var are initialized with a value of undefined. So it's execution and how they are initialized. So now we'll look at hoisting functions some. And if we wanted to loosely classify functions, we could say they're function declarations and function expressions. So let's look at a function declaration. Whoa. And function declarations are of this form and are hoisted completely to the top. This function, and this will shed light on how JavaScript allows us to invoke a function before declaring it, or seemingly before declaring it. So So we see this function is hoisted, and that's because this function is getting hoisted to the top of our scope, which is our global here. So the interpreter is actually seeing it up here, like that. So the whole function gets hoisted. Now, if we were to look at function expressions, let's say expressions look like this. And they are not hoisted. So we get expression is not a function. It evaluates this, and when it gets to this function call here, expression is not a function. Type error. So let's try a combination. Let's make this function hoisting. So we've mixed in a declaration, function declaration inside of our function expression. And let's see what happens. Will this work now? Because, you know, will this be hoisted up and somehow, nope, we still get expression, it's not a function. So as we can see, the variable declaration is being hoisted because we're getting this part like this. That's what our interpreter is seeing. So it exists, and that's why we're not getting a reference error. We're getting is not a function because it exists, but it's not a function yet. So it's hoisted, but its assignment to a function is not. Therefore, we get this type error that it's not a function. So it's important to keep a few things in mind when declaring JavaScript functions and variables, and that is the order of precedence. Now, this is going to be confusing to hear, and we'll walk through it in code, but the order of precedence is 1, variable assignment takes precedence over function declaration, and 2, function declaration takes precedence over variable declaration. So function declarations are hoisted above variable declarations, but not over variable assignments. So we'll see what that means. We're saying variable assignment is over function declaration is over variable declaration. So an example of variable assignment over function declaration. Double equals 22. Turn, let's put it in here. Okay. So here, number. So this assignment is taking precedence over this assignment. So double is being a number and not a function. Now to show function declaration over variable declaration, if we do this, now the type of double is a function. And even if we swap these positions, because of hoisting, double is taking precedence because this is function declaration over variable declaration. And as before, we had variable assignment. Now, lastly, we're going to look at, yes, hoisting classes. I was making sure this was the last thing. Looks like we're doing good on time, perfect on time, actually. We'll get through this and have a little bit of time for questions. And yeah, then be done for the evening. A lot of these things, as long as you write your code where you're declaring and assigning your variables on the same line and writing them in the order that you want to use it, you don't run into these issues. So that's just the best pattern to follow to avoid a lot of this. However, knowing it is going to allow you to debug things way better because you're not always going to write all the code that you work on or that you work with. So classes can be loosely defined as class declarations and class expressions, kind of like functions or similar to functions. So let's write this out. Height equals 48. Sound good? 4 feet. Weight, say 90. I don't know what type of proportions that is. Proto. And then class Hobbit. Constructor is going to take height and weight. This height, GHT, this height, and this weight equals weight. Nope, that's not what I want. Weight. Okay, so this is a JavaScript class declaration, and just like the function counterparts, JavaScript class declarations are hoisted. However, they remain uninitialized until they're evaluated. So this effectively means that we need to declare a class before we can use it. So in our example, since we haven't declared our class before we used it, we get Hobbit is not defined. So instead of getting it undefined, we're getting a reference error. And this is evidence to our claim that class declarations are hoisted. And okay, so as far as class declarations go, if we want to access the class declaration, we have, or to access the class declaration, we have to declare it first. So what we're saying is this class has been declared up here, but we can't use it yet because it isn't defined. It isn't equal to anything. It's new. It's saying Hobbit is not defined. So if we want this to work, this has to be moved to the top or scope, and we use the class afterwards. And we get our Hobbit info. Now, like our class expressions, or like our function expressions, class expressions are not hoisted. So here's an example of an anonymous class expression. Let's say square is a polygon, square dot height equals 10, square dot width equals 10. square. Console log square. Then let's set up this expression. Height and width. I guess I could have kept some of the code from before. We get polygon is not a constructor. So what's going on here is when we hit this new, it's not even recognizing that polygon is a class at all. So it's saying this, you can't call new on polygon because it's not a constructor, it's not a class. So what are you trying to do? Now we can make this a named class expression. And we'll still receive the same error. So the correct way is going to once again be to move this above our usage. And now we should get our polygon. So for your knowledge, but I wouldn't say be concerned with, there are people who argue if ES6 let and const variables and classes are actually hoisted, not hoisted, roughly hoisted, if they're hoisted but uninitialized. Well, some argue that they're not hoisted at all. Some argue that they are. People argue a lot about it. Don't be concerned with that at this point in time. And in conclusion, we want to summarize that while using var, trying to use undeclared variables will lead to the variable being assigned a value of undefined upon hoisting. While using let and const, using undeclared variables will lead to a reference error because the variable remains uninitialized at execution. And so therefore, we should use two things, two tools, two patterns. We should make it a habit to declare and initialize JavaScript variables before we use them. And I think that is taught, and that is the most common pattern. And I think a lot of people don't even need to be told that. They just think that's how it has to be done. And secondly, we should use strict mode if we're going to be writing ES5 code. And that'll help us expose some of those undeclared variables in our code, because we'll throw reference errors as opposed to just letting our code work, and eventually we'll find a bug in it. So any questions at this point in time with what we've gone over? I know we've covered a good amount of ground, but I think it was a nice overview of hoisting. Okay, well, if there aren't any questions, then I want to say thank you so much for coming out this evening, and I enjoyed the time.